As a lead-in to working with partial fractions, I want to come back and review a concept that I hope you worked with a little bit in Algebra 1 and probably pretty extensively in Algebra 2. It's technically one of those topics that also comes up again in pre-cal, but I think it's a nice lead-in to a topic that usually is only taught in pre-cal courses that lead into BC calculus, and that's the idea of partial fractions. So before we get to partial fractions, I want to make sure we're comfortable working with solving rational equations. All right, when I talk about a rational equation, remember that a ratio is something written in the form of a fraction. So we're really talking about solving equations that are written in the form of fractions. Usually, specifically, you're going to see fractions in the denominator. Well, specifically, you're going to see variables in the denominator of these fractions. So here are a couple of pretty typical examples of some different rational equations. And you can approach these a couple of different ways. These actually are in your textbook. I think these are a couple of the example problems early in the section. I think maybe number 5 and number 7. And there are a few ways to do this, okay? One way to think about these is to think about the idea of a common denominator, all right? If you take a look here, I've got a denominator of 1 for this A and for this 4. I have a denominator of A here. And so what I would really like to do is try to get a common denominator for everything, and then we can add together. So, just like if I was adding a half and a third, I would get a common denominator. Same kind of thing here. So if you notice, your common denominator here would be A, right? And the idea is that you can multiply the numerator and denominator of any fraction by whatever value you need to get your common denominator. So if my common denominator here is going to be A, this is A over 1 right now. I would need to multiply the top and the bottom of this by A to get a denominator of A here. I already have a denominator of A here, and then this is 4 over 1, so I would need to multiply the top and the bottom by A here as well. And when we do that, what you're going to end up with is A squared over A minus 5 over A, of course that didn't change, is equal to 4A over A. And now, because I have common denominators, I can add my fractions just like I normally would, or subtract my fractions like I normally would. Actually, before I do that, I'm going to get everything over to the right-hand side here. I'm going to write this as A squared over A. Actually, I'm not going to move everything. I'm going to go ahead and combine these together. So we have a common denominator here we're subtracting. If you think about how you add or subtract fractions with common denominators, you add the numerators, the denominators stay the same. So you're going to get A squared minus 5 all over A is equal to 4A over A. Okay? This is not the only way to do this kind of problem. But the idea here is that if you look at this, the denominators are the same. Okay, so for any value of A, the denominators are the same. What really needs to happen here is that the numerators need to work out to be the same. So I'm really trying to solve the equation A squared minus 5 is equal to 4A, okay? Because the denominators are the same. Those really don't matter, all right? And so anyway, if you notice, this is actually a quadratic. We can move over everything to the same side of the equation. I'm going to have A squared minus 4A minus 5 is equal to 0. And of course, you could use the quadratic formula at this point, or you could factor. I'm noticing here that I think this will factor. We could do an A minus 5, and we could do an A plus 1. And I think you'll get a factorization there. So we get solutions of A equals, looks like positive 5, and it looks like A equals negative 1. One of the things that you do need to watch when you're working with rational expressions is your denominators, okay? It is possible you're going to get extraneous solutions. Specifically, the thing you want to watch out for is anything that makes your denominator 0, okay? If you go back here to the original equation, remember it was A minus 5 over A equals 4. The denominator was A. We can have a negative 1 as a denominator. We can have a 5 as a denominator. So both of those answers are just fine. Okay, so that's one way to do that. Get common denominators. Okay. Now, some of you, I'm guessing, maybe wanted to approach this a different way, and that will also work. The other approach for doing these problems is to try to get rid of your denominator. Okay, and we're going to see both of these options will work for partial fractions when we work with them. So some of you might look at this and say, look, the denominator's A. Why don't I multiply this entire side of the equation by A, and that'll knock out my A denominator? Of course, it's an equation, so I also have to multiply this side by a as well. And so over here, if you multiply by a, you're going to get an a squared. And if you multiply this by a, you're going to get a 5a over a, which of course is just going to simplify to negative 5. And then on this side, of course, you're going to get 4a. And you'll notice, of course, that's the exact same equation that I had before, which has solutions of positive 5 and negative 1, okay? And that actually is probably a little bit quicker and easier, just getting rid of that denominator altogether. But I wanted to make the point here that you really can use common denominator relationships, and they're going to work fine, even if this approach maybe is a little bit quicker. So not necessarily a right or wrong way out of those two options, but I wanted to make sure you have both options. All right, let's take a look at number 2. So number 2 here, and I think this is number 7 possibly in the example problems in your book. This one, we have denominators of t minus 4, and t squared minus 4t, okay? Just like if you're adding fractions and, you had like a 1/2 and a 1/3, and you're adding a 5/6 or something like that, you're looking for common denominators. You're looking for the least common denominator, really. And what you're really doing when you're doing that is you're looking at the factorizations of each of those numbers. 6 is 2 times 3. And so what you can see is, oh, I'm missing a factor of 3 here. I need to multiply the top and bottom by 3. Oh, I'm missing a factor of 2 here. I need to multiply the top and the bottom by 2. Now we'll have 6's in all the denominators. That's our least common denominator. Same kind of thing here. You need to look at the denominators and see, are there any factors in common, okay? Which means you need your denominators to be factored, okay? You need to see, can I multiply by anything to get the same denominator for all parts? So on a low level, you can just multiply all 3 of these together. But factor first, because sometimes you're going to find out you don't have to multiply all your denominators. Here, you can factor out a GCF of t. You're going to get t times t minus 4, and you'll notice those are the 2 parts. We've got a t here and we've got a t minus 4. So our common denominator is actually going to be t times t minus 4, and that's going to make our life a little bit easier in this problem. So for example, you can take this t plus 4 over t, and you want the common denominator to be t minus 4. So you can multiply the top by t minus 4, and you can multiply the bottom by t minus 4, right? That's the same thing as 1, so we're not changing the value of the fraction, we're just changing the denominator, basically. And then same thing here, you've got plus 3 over t minus 4, okay? Our common denominator here needs to be t times the quantity t minus 4. So you can see here, this needs to be multiplied by t in the numerator and in the denominator, and then we would have the same denominator that we have with this other term here, okay? And it's equal to negative 16 over t times the quantity t minus 4, and of course that already has the common denominator. So we can simplify this out a little bit. Here in our first term, we're going to have a denominator of t times the quantity t minus 4. The numerator, of course, is just going to multiply these 2 values together. That's going to be t squared minus 16 because it's a difference of squares, okay? Here, you're going to get 3t in the numerator, and of course you're going to have that t times t minus 4 in the denominator, and then over here it's going to be equal to negative 16. We don't have to change anything there. Notice now that I have 2 fractions with the same denominator that are being added. So I should be able to add the numerators, keep the same denominator there, and I'm running out of space on my board here, so I will add those numerators. And what we'll end up with when we add those numerators, we'll end up with, we had t squared minus 16 plus 3t all over t times t minus 4. And again, you might want to order this around. You could write this as t squared plus 3t minus 16. But here's the key. I have 2 fractions. They're equal, okay? Notice, regardless of what I put in here for t, as long as I put in a t that's not going to give me a denominator of 0, these 2 fractions are going to be the same. So the denominators don't matter. I need this to equal this. That's really what's going on here, all right? So anyway, if you set this numerator equal to this numerator, I need t squared minus 16 plus 3t to be equal to negative 16, okay? Notice I can add 16 to both sides. And if I add the 16 to both sides, I'm going to end up with t squared plus 3t is equal to 0, okay? And of course, you can factor out a t here. You're going to get t times the quantity t plus 3 equals 0. And at that point, we can see here that t is either going to equal 0 or t is going to equal negative 3. Now, again, be careful. If you go back and look at the original equation, t minus 4 can't be 0. Nothing is going to make t minus 4 equal to 0. However, t can't be 0, okay? And if you notice here, that would give us a 0 denominator, which of course is not possible. So that's an extraneous solution. T equals negative 3 is going to be the only solution, okay? Now, for those of you who say, gosh, all that common denominator stuff was complicated and it was time consuming, can we do this in a way that's a little bit faster? The answer is yes. So the second approach here would still be to find your common denominator. Okay, so you're going to need to factor that first denominator. And hopefully you notice that, of course, the common denominator is the product of any of the unique factors of the different denominators. So our common denominator is going to be t times t minus 4. What you can do is you can try to eliminate those denominators. In other words, multiply the top of your fraction by your common denominator, and it should knock out all of your denominators. So if I've got this t plus 4 over t, and I've got this 3 times t minus 4, and I've got this negative 16 times t over t minus, t times t minus 4. I can take the whole thing and multiply by that common denominator of t times t minus 4, okay? And what that's going to do is it's going to multiply the numerators by each of those values, okay? So look at what happens, though. Some really nice simplification is going to happen here. So if I multiply this first t plus 4 times t minus 4, I would have a t times t minus 4 times a t plus 4, and it would all be over t. And notice, I've got a factor of t in the numerator and denominator. Those two things cancel, and I no longer have a fraction. Okay? Now, this term of 3 also would get multiplied by both of these. So I would have t times t minus 4 times 3 in the numerator. On the bottom, of course, I would just have this t minus 4. The t minus 4s can be divided out of the top and the bottom, and I'm left with just a 3t, which of course is no longer a fraction. Okay? Because what's going to happen is, by multiplying by that common denominator, every one of those denominator values is going to divide into that, and they're going to cancel, and you're going to be left with no denominators, is the whole concept. Okay? So over here, if negative 16 is also multiplied by t times the quantity t minus 4, you're going to have negative 16 times t times the quantity t minus 4, and then of course you've got t times the quantity t minus 4 on the bottom. Once again, t minus 4's cancel, the t's cancel, you've got a negative 16. So in the end, notice, all of my denominator values canceled when I multiplied by the common denominator. It knocked out all of those denominators. I'm just left with t squared minus 16, and I'm left with 3t, and I'm left with negative 16, and our negative 16's cancel, and I've got t squared plus 3t is equal to 0. I can factor, and we end up with our solutions of 0 or negative 3. We just have to remember that I can't have a denominator of 0, and so we have our extraneous solution. T equals negative 3 is the only solution that's going to work there. So again, you can find common denominators. You can add and subtract your numerators. You can match up your numerators since your denominators will be the same. Or if you just want to multiply everything by your common denominator and just knock out your denominators in the first place, either one of those methods should work.